Good morning, everyone. This is Jim Nasser. I'm one of the leads at the HR Foundry and really delighted to do our next town hall in our series of town halls. And today we're going to be speaking with a couple of the deep technical folks in the Hedera community, and we're really excited to do that. And I have a co-moderator with me, Viv from the HR Foundation, and he's very heavily involved with a lot of the technical reviews that the HR Foundation does. I think a really good group. Before we get into introductions, I'm certainly going to have the speakers and panelists do that themselves. I'm just going to give you a little bit of background about the HR Foundry and this town hall in particular. So the Foundry is a decentralized group of Hedera developers that have been around for about 3.5 years now, since 2020. And we get together every Friday. There's been a community meeting every Friday at 11 o'clock Eastern, and that's been going on, like I mentioned, for over 3.5 years. And since then, particularly in the last year or so, we have developed these offshoots, such as these town halls, some projects, and some additional educational things to really bring the community together to speak about things that are relevant and are interesting, and hopefully help everybody, and particularly to help collaborate and support the developers in the Hedera community. If you're interested about HR Foundry, the website is hrfoundry.com, and I think there's social media on LinkedIn and Twitter as well. Yeah. So this, like I mentioned at the beginning, this town hall really is a deep dive, a technical deep dive, and we want to help the community understand some of the infrastructure, some of the technology, some of the strategy that's happening within the Hedera community, and really is supporting developers. With that being said, I'm going to ask our panelists and also Viv to introduce themselves and give a little bit of background about themselves. So Viv, maybe you could start, and then we could go from there to Richard and then Nana.
Sure. Hello, everyone. Welcome. It's an absolute pleasure to be here. So I'm Chief Information Officer for the HR Foundation, and I wear a few hats, but primarily I'm focused on some of the strategic elements of the foundation, in particular how we focus on ecosystem growth. Developer experience in particular is one of the key areas, as well as tooling and some of the other pieces around, how does Hedera become one network and a prominent member of a multi-network, multi-L1, multi-L2, whatever the case might be, ecosystem, especially targeting the builders out there. So my background is in distributed systems. I primarily focus on, as Jim mentioned, some of the due diligence and the pieces that we do around some of the funding that we provide to our grantees. So I've been in Foundation more than 2 years, and pleased to be here. Over to you, Richard.
Hey, thanks, Viv. So my name is Richard Bair. I lead the engineering group at Swirlds Labs, and I'm recovering from a cold. So you got like the gravelly Richard today. I'm great to be here. I hope we get to come more often, and it's great to be able to talk with everybody about all the stuff that we do. I think that, my background, I've been doing, software engineering for 25 years, Oracle, Sun Microsystems, and Hedera in here. And, we build big complex systems, what we do. So what's really exciting about working on this one is that it's like a system that needs to be fast. It needs to have no bugs. It has to have a lot of features, and it has to be completely decentralized. It's like the trifecta or quadfecta of the most difficult problems that you can solve. So it's a very interesting problem set for someone in the industry. And we have lots of really, really bright minds that are here, a lot of good engineers. So it's a privilege to be able to be here and work with them. And Nana's one of those. He's leads the smart contract side, but does so much more than that. I'll turn it over to Nana.
Yeah, thanks. My name is Nana Essilfie-Conduah. Like Richard mentioned, I lead the smart contracts team, focused on everything smart contracts on Hedera. So I'm really interested in sort of the ecosystem's goals, especially pain points, anything that has to do with the EVM. Our team would love to learn more. In terms of backgrounds, being an engineer for about 16 years, I guess. done some consulting, systems engineering, and others. And so, I really like to understand what people are really trying to achieve with the network, and then see what we can do in the meantime to help.
All right. Well, thank you, Nana and Richard. I appreciate that, and Viv. So I would like to just start maybe with a higher level conversation or question, and then conversation around the technical strategy and the roadmap for Hedera. So perhaps, Richard, you could maybe start with that, and just as much as you can share, just share kind of what is the current, if you like, roadmap that you have, and some of the elements of strategy that you're considering.
Yeah, you bet. So I think that one of the things that kind of, so what the right way is to say this, we're always very cautious in terms of making a commitment. If we make a commitment, we want to absolutely hit it. And that kind of goes into the enterprise background that we have. And so consequently, there's a lot of good stuff going on that might not be published publicly yet, just because we're not 100% sure that we can hit it. So we're always going to defer on the side of making sure that if we say something, we can do something. And so, if we were to look at our roadmap and say, what are the things that we're most focused on? What are the things that concern us the most? And I'm talking about on the engineering side. And if you ask Viv the question, he'll have a different set of priorities of things that he's looking at. He's looking at a lot of integration points, things like that. On the raw engineering side, the thing that we mostly, first priority is a smooth and well-functioning network. Every number that we publish is honest to goodness, like what we can do. We're honest about the work that we do. And we have a lot of tests, a lot of things like that in order to try to make sure that we can actually hit all those numbers that we publish. So making sure that the network is safe and secure is absolutely always the top priority. And any other priority we have will get bumped for that one. Outside of that, the next priority is feedback from the community. So we want the experience for the people who are building. I mean, if you looked out 2 levels, the experience that we want for end users using our network is that we have the best user experience. In order for that to happen, we have to provide all the tools and capabilities to the builders so that they can give users the best user experience. And in order for that to happen, we have to get a good dialogue and feedback so that we know what features to add. Because I've been in the platform business a long time. I was on the Java team. We developed a platform that obviously is used by many millions of people, excuse me, and billions of lines of code. And there's 2 things that we really learned from that experience. The first one is that backwards compatibility is absolutely important. We can't break people. And the second thing is that as a platform provider, you always live in a bubble. You do your best to try to understand what other people need, but you always live in a bubble. So the things that we try to focus on is like, what are people telling us? What are the pain points they're telling us? And sometimes they tell us a pain point and we go, I don't understand. How can that be a problem? And that's actually a very interesting, like when that happens, that's the most interesting thing. Because if somebody says, hey, this is a problem, and you say, how can that possibly be a problem? It means that there's something that we don't understand and something that we need to understand better. And when we understand it, we can provide a better experience. So I think airdrops is a good example of one of those where, I personally have always been on the end of the spectrum that said, I don't want anybody's dirty airdrops, just leave me out of this. I want to have a clean account. But we've heard like loud and clear from people that are saying, dude, we absolutely need airdrops for a whole bunch of different use cases. And so that, was something that we had to wrestle with. And so an example of that is like the airdrop HIP that we produced. It was the result of, I don't know, Nana, it's probably at least 20, 25 hours of discussion to try to work it down to something that we felt would be a good compromise between the 2 extreme positions. So I think like airdrop HIP is a good example of something that goes onto that roadmap.
So just on that HIP, Richard, are you able to give us, for those tuning in, does one even say that anymore, tuning in? For everyone else on the call, can you dig into a bit more on the frictionless airdrops and what sort of the benefits are? And I guess, BlackRock had a bit of a unfortunate series of events that happened with their recent Ethereum-based with their recent Ethereum-based launch. So I guess can you sort of give us some commentary in the context of, how Hedera might have, been able to, I guess, prevent or mitigate or even altogether just eliminate such classes of, network behavior, pretty much, torpedoing what would have been a pretty serious and meaningful launch?
Yeah, I think I could probably tee it up and then let Nana dive into it, because Nana really drove the effort to get us across the finish line on this thing. I mean, it was like, for months and months we had talked about, well, what if we do it this way? What if we do it that way? And Nana sort of took the bull by the horns and scheduled all the meetings and got all the right people there so that we could get through it. So yeah, Nana, why don't you handle that question?
Yeah, there's a couple of contextual things I'd like to clarify. Hedera is a network, right? So as Richard said, we're trying to enable people, right? We're trying to enable developers. We're trying to enable users. This means that we have to understand multiple personas and perspectives. Hedera native services, for example, had this idea around native tokens, right? We wanted to be able to provide tokens that could transact at the speed of native transactions, so they can go as fast as crypto transfers and they can do everything else. They do this off of the EVM. However, as a ledger, we're also EVM equivalent and compatible, meaning that all the smart contract EVM scenarios that you want to carry out can be done on Hedera. This means that we have at least two personas. One persona that says, I want to transact with native tokens that have these properties, and one persona that says, I want to do the same thing that Ethereum and others have done for 5 to 6 years on end. And we want to enable both these people to have like first class experiences, right? So on the EVM side, really tokens they're just balances within a smart contract. That's really all they are, right? And so there aren't, unless a developer adds them, restrictions that say the ledger for your account can't have these tokens, which is where you get airdrops from. It means I can just send tokens within that contract that relate to your balance. There's no real permissions innately within it. And if you compare that to Hedera, where we say that, okay, tokens are these native entities and they're complex and they have characteristics about them. And part of that characteristic is account sovereignty, right? So we want anything that has to do with your account to be in your permission. Anything that changes on your account should have been signed off by you. So if you don't want to have a token associated with your balance on Hedera, you don't have to. Innately and by default, you won't. This is where a token association comes in and says that, hey, there's a token out there. I like it. I want to hold this balance. I go and associate with it first. And from then on, you can transact with it. And so the HIP 904 frictionless airdrops, it really is an effort for us to be able to support both these personas. We want to be able to maintain that account sovereignty and allow people who, have really, core scenarios, maybe in the finance space, where it's really important to make sure that exactly what's going on, what changes are being made. But you also want to allow, whether it's retail scenarios where certain tokens on the EVM want to be transacted, or even native tokens in a fashion that's a bit more open. So what we're doing here is we're kind of splitting it up in what we call max or I'd say automatic associations. There's a property on the account that allows you to define and say, hey, I'm open to accepting all tokens or no tokens. And by choosing one of these pathways, you can essentially support airdrops. So by default, if you create an account on Hedera, it's the former, right? It's the default, it's the restricted, it's the you have to associate with a token before. But if you are coming through, let's say the EVM side, and you automatically create that account that doesn't have the perception of Hedera level qualities, you'll go the EVM route that says that, you're willing to accept airdrops, meaning, Viv or Jim, you could send me a token and it would work just as you would expect on other EVM networks. We also made some other improvements that I won't go too deep into, but we did some balancing out of who pays for that association. And then one extra thing that we also added is this concept of token rejection, right? It's really important that I, as a user, again, for that account sovereignty reason, I should be able to get rid of tokens in my account if I feel the need to. Because Hedera also has these properties around what we'd call custom fees. Custom fees are another initiative to enable, token makers to be able to sort of track these fees, that as you send them, whether it's royalties, that token owner could, get a percentage of that. But sometimes these can be used maliciously in the fact that I could send you a token and I could put a really, high custom fee on it. And then effectively you wouldn't want to get rid of that token, or you couldn't afford to get rid of that token even if you wanted to. So token rejection is another aspect within this HIP that will allow you to get rid of any token, regardless of how you acquired it, whether you manually went and associated or it was automatically associated for you. So if you had a spam token that came in, you could send that back to the treasury. You wouldn't have to pay the custom fees. You just pay the minimal transaction fee to actually submit it to the network. And that really provides a really safe pathway for users to continue to maintain their accounts. So in a nutshell, that was it. But actually, there's one more. I forgot. A big part about the airdrop is also the account that wants to maintain their sovereignty can still do so, but accept airdrops later on. So this means that if I have my account that's somewhat locked down and it's important to me to see every token that comes in, I can still be on the receiving end of an attempted airdrop. So in this call, Viv, you could try and airdrop me a token. It stays in your balance. It doesn't come to mine, but the network, in a sense, it registers the fact that you intended to send that token to me. I then, as a user, have the opportunity to go and claim that airdrop that you sent to me. I don't have to, but I do have the opportunity. And so in this way, again, I can maintain my account sovereignty as to what comes in, but you as an airdropper have a smooth experience of being able to submit a transaction that would attempt to airdrop a token to me, if not allow me the opportunity in follow-up to be able to claim that token. And it's sort of akin to what some other ledgers are doing when they find out that maybe you have a governance token for a network or for a project, and they say, hey, come over, do this step, and then I'll mint this token for you. It's sort of similar to that in this regard. So I could, airdrop this token. It doesn't go through immediately to your balance, but then you could take a step later to go claim it at your leisure. Yeah, I promise that. I promise that's a summary for it.
That was really good, Nana. And again, we could speak. Viv brought up this issue that BlackRock faced just recently, and we could definitely delve into this at length. I think the folks at Hedera Devs did a really good job on Twitter, just explaining what the problem was, what are the things Hedera does. But this idea of token rejection, I think if that was there as example, would have been very, very handy because of the way the primary crypto wallet had been tainted with the junk token, and that's a real issue. And of course, we all notice that the scammers they tend to be like a half a step ahead of everyone, and they come across these new creative ways of exploiting loopholes and ways in which you can basically taint or really kind of take down a number of things that are out there as utility. But I think one of the things that I love, and I love that you guys are preemptively and really proactively looking at this, is to have mechanisms built in to address these things before they become a real issue, and informing, like you were mentioning, Richard, that feedback from the community is so critical in terms of what your roadmap looks like, and understanding that these are some real use cases that are happening, and addressing those so the builders are protected and we're not dealing with a lot of junk and having to do rollbacks and things like this that create obviously a lot of issues for a lot of people.
And also, I think, Nana, you brought up a very interesting point around the recipient having choice, and especially in the context of BlackRock or any other financial services. This proposed accept pattern is a really powerful thing, especially from a legal perspective when it comes down to any, I guess, disagreements that require adjudication, because a very clear notion of, as you said, on the ledger, the ledger records an indication that I've intended to transfer you a token, but then you have the choice to reject, accept, or do nothing. And the do nothing might well fall back into a reject anyway. And this as very clear and distinct set of choices makes it quite clear to trace through the life cycle of, let's say, this represents an asset or whatever the case might be, should it ever require any kind of, legal, I was about to say interference, but I mean, oversight, let's say. But just, while I've sort of got the talking stick, there's a question from the audience. Is there a time limit for claiming an attempted airdrop?
Currently, there is not. One thing that's unique about that is because the token stays with the sender, it's akin to any other token that's in their balance. It's really just that intent that is captured. And one thing to clarify from your previous comment, I just want to make sure people don't get confused. Again, the token hasn't left the sender's account. It's still in theirs. So there's no concept of rejecting a pending transfer. Rejections are only for tokens that are already within your balance.
But the sender can cancel it.
Correct.
So if a sender creates a transaction, says, "Hey, Viv, here's a token you might want," and if you don't claim it and they cancel it, then the pending transaction is canceled and you cannot claim it.
Yep.
And the sender has to pay. When rent is enabled on the network, the sender has to pay rent for each one of these tokens that have not been sent. So it's in the sender's interest not to keep it open-ended forever, which is also how we prevent a sender from attacking the network by creating lots of pending transactions. They have to pay for them. And if they have to pay for them, then they'll probably act appropriately.
Exactly.
Yeah. So this is a very rich topic. We could spend probably the rest of this town hall just going through this, but there are many other interesting things that we should get into as well. So Richard, I want to circle back to one of the comments that you made in your introduction, really around meeting the commitments that Hedera has, right? And there are a lot of commitments, being very, very fast, being extremely secure, being able to scale. So can you please walk me through your process as a VP of engineering? I know you oversee much, if not all of this. So just walk me through your process of how do you do this? Like, how do you, in reality, meet the challenge of security, being, as secure as possible, as fast as possible, scaling. I know there's a lot involved, but just give me a feel for what you do and how you meet this, including perhaps areas that you get into in terms of regression testing, load testing, security, pen tests, all of that. I'm sure all of us would be interested in understanding a little bit more on kind of what you do in the process.
That's a great question, Jim. Thank you. I mean, I felt for a long time, it's like, we need to take some time and write up a blog post on this or something so that we can get it all published out there, because we're very rigorous about the approach that we take to this. I think that as a team, the culture that we have is definitely not cowboy. It's definitely enterprise, and a large bunch of the team has come from the large enterprises, so we're sort of have that in our background. So when we have a fix or a new feature or something that needs to be introduced, I mean, there's a lot of aspects to this, but I'll just take sort of the journey of a fix as it is made to how it finds its way out into production. So you have some fix and you want to find its way to production. Of course, you have to write some unit tests for that thing. And you have to execute all the other body of unit tests that we have. And once we've executed all of those, we also have a series of, at the services level, we have what are called happy tests. And because these are tests that test the Hedera API. And for those to run, we actually set up a small network of nodes and we execute the tests against that small network. This enables us to find a variety of different issues that might not have been caught at the unit level. And we also have a bunch of other integration tests that we run. And all of these are done on every single branch before they're merged back. We also have, security scanning, static analysis, a bunch of other checks and gates that go into it, making sure that we've got, a couple of people who have reviewed it. We have code owners so that somebody from a different area of the code can't just submit a new change in your area without you knowing it. You have to be one of the reviewers to make sure that it got reviewed properly. So there's a lot of different checks and balances that go into it, but all of that happens on every putback that's going to get merged. Once we have it merged in, then we execute a nightly performance test. And when we run this performance test, it's across, a set of nodes, and we turn off the throttles and we run the thing completely unthrottled. And it has sort of self balances to figure out what level it can achieve, which allows us to look for performance regressions before they get significant. So we can compare the results of one performance run to another performance run in order to verify, a trend. We can just, plot some kind of a trend line, see if things are getting better or worse, things of that nature. And when we do performance tests, we have a couple different ones. We have some, like we do NFT transfers, crypto transfers, smart contract calls, a mixture of all three different types, consensus service, a mixture of consensus service with the other types, and so forth. There's a variety of different combinations that we run. And we run those every single release. And we also have what we call the Oleg tests, because it was written by Oleg Nazarov, who's on our team. And he's I don't know, he might be up to 30 years now as a performance engineer. He was at Sun Microsystems back in the day. Has a lot of experience as a performance engineer, and his tests are absolutely brutal. It's like, in the NFT transfer test, we mint very large number of accounts and NFTs, and it just keeps track of the trading of those things back and forth between all the different members. And you guys have known this for a long time. The numbers that we have as our throttle are sort of a safe level. We actually test way the heck above that. So give you an example. In these performance tests, we see 200 million associations, whereas our actual limit in mainnet today is 15 million. Now you'd say, well, why can't you make it bigger? We can. We're just very careful to make sure that we're not going to mess up mainnet no matter what. Which is why our network can crank out 1 billion new transactions every 7 days or every 10 days. And I don't even think about it at night. It doesn't even come into our mind, because we have tested this thing to the T. We also do chaos testing, where we run at max throughput, and then we just start killing nodes. And then those nodes reconnect. So for those who aren't familiar with that terminology, basically what happens is every single node in the network has to be up to speed with every other node in the network, because every single node has to process every transaction, get its final result, share the final result with everybody else, and say, yep, we all agree we processed that transaction correctly. Well, if a node goes offline for even 3 minutes and you're doing 10K TPS, there's a whole lot of transactions they missed out on. So what they do is there's this process called reconnect, where a node will sync up with another node and get everything that it missed in those 3 minutes, and then it'll pick up and start executing again. So we have nodes that go through the reconnect process, and and we kill multiple nodes at a time, making sure that it stays above the 1/3 threshold in order to verify that we can recover and everything is good. And it's one thing to say that you can process 10K TPS. It's another thing to say that you're processing 10K TPS with reconnect. So if you just did the back of the envelope math on that, and let's say that you did 10,000 10,000 token transfers per second, and your node was offline even for 30 seconds, that's like, well, I don't know, 10,000 times 30 seconds. That's 300,000 different modifications that have happened in that time period, and you have to synchronize all that and catch up. So which means that all the nodes need spare capacity. So we go through all of that. We do a longevity testing, which by default is a 7-day process. And in longevity testing, we do the chaos and the heavy load for 7 days straight. And if the node, nodes die, or, one of the nodes computes something incorrectly, then that becomes like a P0. We go figure out what happened. We get a bug fix. We put it in. So yeah, it's a pretty rigorous testing strategy. I think in terms of what we're trying to do next in our testing is, currently the way that our development process works is that we do some work. We get ourselves a build fairly close to the testnet release. We run it through the longevity testing, about a week before we run the longevity testing. And then we go, okay, now we've got some final result. If it passed, we're good. We go to testnet. If not, we don't, which sometimes means that we have to move around our testnet release date because we found an issue. So what we're doing is we're moving to a process where we're actually going to have at least 5 concurrent longevity networks going. And each one of those is going to be running a different daily build. So there'll be a Monday build, Tuesday build, Wednesday build, Thursday build, Friday build for each one of those 5 different networks. so that on any given build, if it's green, we know that it's available to go to testnet. And if any build is red, then we'll know that we have something to fix. And we'll start running those things from, each day through the process. So we don't wait towards the end of the release to figure out, oh dear, we've got an issue that we need to resolve, something that we've introduced in this release. But we'll be able to discover that much closer to when it actually happens. And we're also going to have a sixth network, which is a mini longevity, which runs all the same sort of stuff that's in longevity, except it does it in a single day instead of in 7 days, so that we can get also a fail fast, figure out that this thing has failed as soon as possible.
Wow. That's amazing. Vip, I know you had a question you wanted to follow up on, but just one comment, Richard. Again, we saw this. I think a lot of us who follow the network saw this last 10 days or so, that you had made some comments, just really, about the rigor of what you do and all of the various testing and the way the builds are done. I didn't even realize the details of the chaos testing you're doing. So that was this 5 longevity networks they have. That's amazing. But this idea that they're able to kill nodes and reconnect them, I think that's incredibly powerful. And I think you had mentioned that on some tweets and communications that you had regarding something else that was a little bit of a kind of a FUD about network performance. But I think that's, again, just understanding the depth of that, even to me as somebody who's been in this space for quite some time and has been building infrastructure, that's really impressive. That is not that's not a trivial engineering kind of feat, right? That's a significant process, and you keep doing it. And so kudos. I think those are the kind of things that we hear. We hear TPS, it's 10,000, it's threshold and things like this, but to hear that and map it to the operations that go with it, and the serious engineering and the DevOps and network management, and to keep everything secure, I think that is very impressive. So kudos on that. I'm sure that keeps you up a lot.
Yeah, it's a lot, but it's what allows us to sleep at night. If we didn't have all those things in place, then when testnet goes to 10K, we'd be like, oh dear. But yeah,
absolutely.
We don't even have to think about it really.
So
yeah, go ahead.
Yeah,
I did have one other interesting tidbit. Yeah. So another thing that we do really well, and they did this, before I got here, I was really impressed with what the team did, is keeping track of metrics. So anybody who's built these sorts of systems before, how important it is that your system generates metrics, and it all goes into some big Grafana dashboard in the sky and some Prometheus, and you can query it and all that kind of stuff. So we have, I've lost track of the actual number now, but it's, several years ago, it was 700 metrics. I think it's probably more than that now. But we have many hundreds of metrics which are exported from all these nodes to central location, and then we have alerts that are based on them. So I think one of the things that people asked about was like, hey, how did we hit that entity limit a couple of weeks ago, right? Because I told you, we tested it at a much higher number, but it was at 10 million. How come we didn't realize that we were going to hit 10 million until we did? The truth is that that was just it was an oversight on our part. We had the metric that told us that we were approaching it, and we just didn't have the alert on that metric. So we did a broad review of all the different metrics that we have, looking for anything similar that would be an entity limit that we didn't have an alert on. There was one other one that we found that we've now added that alert to that. So hopefully we don't trip up on that problem again, because to be very honest with you, our emergency response is very robust. I literally woke up at 3 a.m. for that one. It was, we have the pager duty hooked up to those things. If any of the nodes trip a wire, we do get waken up in the middle of the night, literally, and then try to remediate it as quickly and as safely as we can. So, so in terms of metrics, we have like a ton of metrics. And in fact, if anything is a problem with it, it's just that there's so many metrics that making sure that you're getting the best signal for all of that is the real challenge. But the team has done a great job building some really amazing dashboards and alerting on this stuff. So we have a pretty good idea when we get there. So for example, we just recently tripped over the 70% done alert threshold for that entity metric. And we'll be raising the limit on the number of those entities that we have in the next release to compensate for. So we keep track of these things so that we can make sure that we stay ahead of the curve.
So I actually had two questions, and you've just answered one of them, because you made the comment, if a single node, computes something differently, that raises P0. And I was going to say that at that scale and with that degree of repeatability that is evident from what you've described, there must be a absolute ton of instrumentation and reporting systems that you'll have in place. But I think you've given us a very nice peek under the hood there. But I did have another follow-on question, actually. So in terms of when you started talking about some of from the unit test to the integration test and so forth, and also some of the corollary tests around security and all that sort of thing, how does this compare to some of the other L1 networks out there, to the best of your knowledge?
In terms of the security work and how that,
and the level of rigor and the breadth of the testing that we do.
So I can't really give a good idea of what all of the other L1s are doing. I assume that I know that from the work that we've done in Ethereum that they have a very large body of tests that they execute for EVM and so forth. But what's interesting is that the nature of the problem is different for us than it is for many of the others. At least if you looked at Bitcoin and you looked at Ethereum, you would say that Bitcoin and Ethereum are both leader-based protocols. And it may not seem that way, because it's like, well, who's the leader? I mean, Solana is also a leader-based protocol. It's like, well, who's the leader? In the case of Solana, there's some pseudo-random selection of who the leader is. In the case of Ethereum, or Bitcoin, especially under proof of work, it's kind of like you figure out who the leader was after the fact. A whole bunch of people claim to be the leader. They say, hey, I generated a block. Everybody validated it. Whichever one is voted the most ends up becoming the leader for that. Because they're leader-based systems, it has in place MEV and front running and all the other sorts of things that you can do. However, there's a certain robustness also that they get from it. Whereas on our side, because it's much more democratic, every single node has a vote to say, what it's done, and did it do what it was supposed to do. And because of that, because of that democracy, if you will, we have to be very, very rigorous in making sure that the all honest nodes come to the right conclusion. And in the case of Ethereum, if one of the honest nodes, or if a node that is actually honest but comes up with the wrong solution, you can't really tell the difference between that one being honest and dishonest. But everybody would end up voting for somebody else because they can see the block is different. In our case, something similar happens where, so what happens is every single node processes every single transaction. At the end of each round, which the Hashgraph paper defines what a round is, and let's just say for sake of argument, a round is about every second. So we process, 10,000 transactions roughly. It's the end of the round. We compute a hash that represents all the data that was in that system. And then they all gossip that hash with each other. And they say, hey, did I have the same hash that you had? And anybody who's an honest node who gets a different hash than the 2/3 majority will say, wow, I really screwed up. And it'll go through a reconnect cycle. It'll say, all right, I'll throw away what I've got and I'll get whatever's new, and then we'll connect from there and go. So there were certain things that we baked into the protocol in order to create that kind of robustness, so that if any particular honest node messes up, it has a way to get back on track. And these events are known as an ISS, and we've also had a lot of debate over what ISS means exactly, but I think invalid state signature is the current name for it. But because what happens, it's either invalid state signature or inconsistent state signature. I can never remember which one it is, but we just call it.
I guess space station is right out.
That's right. But it's just that moment when everybody compares and they go, oh, dang, I have a different state signature than everybody else does. Okay, I'm out. But I think when it comes to security also, there's like people think of, well, your protocol has to be secure from the perspective of somebody who's trying to, hijack your node through like gRPC or something like that. But we also have another level of security where it's we try to prevent anybody from being able to do exhaust resources. Let's say any sort of resource exhaustion attack. So, for example, making sure that the pricing is set appropriately and that there's not any way for somebody to do an action that costs less than the price. So, for example, on the smart contract side, we had this huge body of tests that were called CART EVM. If you went and looked into our open source projects, you probably see CART EVM there. but it was a Cartesian product of every different, combination of every different EVM opcode instruction that was available. And we executed all of them in a really tight loop to see how much computation was being used relative to the amount of gas that was priced. And we did that in order to make sure that there wasn't any combination of opcodes that you could execute that would allow you to do more work than what you paid for. So there's a whole other layer of security that goes into this beyond just sort of, can somebody hack your machine security? There's also the, can somebody exhaust your resources security? Can somebody exhaust your throttles security? So there's a whole bunch of other aspects of security as well that goes into it.
It's very rich, very, very rich, Richard. And we could definitely talk security maybe the entire time. I do want to change tack just a little bit and get into the, particularly into the software development kit and the toolkit compatibility. And just maybe Nana, you could help just give us a little bit of understanding about how does Hedera keep up with the SDK and the TCK and the process around that.
I'll talk to the SDK part, and then I might swing it back to Richard for the TCK.
Sounds good to me.
But, I think Richard already laid out sort of the robustness of the development process. There's also a whole other suite of, I'd say, design and production level processes that go in before any feature is actually developed. It goes all the way, starting with the hips. Everything is open source, so if you follow our GitHub repos, you'll see the tickets and the issues. They're assigned to sprints and milestones. And so the SDK is our products within the ecosystem. So you'll see the consensus node as sort of the origination of a lot of these features, as well as, the protocol level. But if there's an impact to developers, if there's a new transaction, if there's a new property, the SDK teams will know of it. It will be on the development process. It will be on the boards that we use to track it. And so if I take, HIP 904 with the frictionless airdrops, you'll see that there's an SDK section in there that calls out the new transactions. It calls out the fact that the SDKs will expose these transactions. So right after the protobufs that are designed, the protobufs being sort of the scripted interfaces of what Hedera APIs look like, the mirror node as well as the SDKs are able to pick these protobufs up and begin to develop in tandem or in parallel to the other products. And so the core of that is, good product development. We have PMs, we have, engineering managers like myself who stay on track with these, make sure that the affected products are in the know, and, SDK development can go in parallel to make sure that at the time the consensus node exposes a new feature, the SDK is already ready and there. And also, as part of the tests that Richard mentioned, the SDK tests are also part of that, right? We're going to test that a new transaction can be submitted during that longevity test or during that high performance test. Those tests are necessary to sign off on the feature. So in a sense, if the SDK hasn't exposed it, we can't test it. If we can't test it, we won't ship it.
So Nana, to be clear then, if I understand this correctly, you won't be able to, unless the SDK is also fully done, fully completed and tested, you will not be releasing it. Is that what you're saying?
A feature, correct. Because we're in a sense, exactly. I'm trying to see if there's another word other than dog fooding, but we want to make sure we understand the experience of developers, right? Yeah. And so most developers are using our SDKs as we recommend. So we need to make sure that the SDKs work and support the features that we're building out.
Yeah, I really like that, because that obviously for those of us who do come from an open source background, that is, that's the typical process that you have in an open source initiative. But it's great that we have this rigor. Obviously, we have this rigor. Maybe we don't necessarily recognize it, already at Hedera. Okay, and is there anything else? So on the SDK, are there any other considerations you have that you consider?
I think probably the TCK is a good one.
Yeah. Maybe you could explain that a little bit.
Yeah, maybe I can step into that. So we started the project, but it hasn't completed yet. That's for sure. The TCK is a in-process project. But essentially, what we had been doing was every single SDK had its own test suite. There were some unit tests, and then there were some end-to-end tests. But as you can imagine, we have I don't know, a half dozen different SDKs. And there's divergence between what each one of them was testing and how they were testing it. And we also have some SDKs that are not being, written by this World's Labs team, and we want those to be, tested and certified as well, so that we, everybody's sitting on the same playing field, if you will. And so what I wanted to do is I wanted to create a technology compatibility kit, which is what TCK stands for. I wanted a compatibility test suite that we could use in order to verify the compatibility of one SDK with other SDKs, like how well do they actually implement the different Hedera APIs, and does it all work? So that was where the idea for the TCK came from. And the idea is that we would have one big body of tests that go through a whole bunch of different scenarios. When you use the TCK and run it against an SDK, it will set up a set of nodes, and it'll then call some API on the SDK. For example, like do an account creation. And it does account creation, and then it says, okay, what was the, what error code did we get from the SDK? No error, everything worked. Great, that's what I was expecting. Did it show up in the, record stream? Did it show up in the mirror node? They'll be able to poke the network. So it's not just trusting what the SDK does, but it'll call the SDK, say, what did the SDK say it did? Then we'll go check the network, say what the network said it did. If everything passes, great, we'll move on to the next test. And, it'll be one of those things that sort of gets built out over time. But in its full analysis, there should be, tens of thousands of tests that run in this thing. And it'll not only help us catch any sort of regressions, but it'll also help so that anybody who wants to write an SDK, like let's say that you go, okay, your guys is, Go SDK. I just hate it. I want to write a new one. Cool, go for it. And you can run the SDK or the TCK against it. And if the TCK passes, then you can publish those results and say, here's my Go SDK that I wrote, and it passes all of the tests. Everything looked good. And then people would have some level of confidence with it. So that was really kind of the idea behind the TCK.
Yeah, no, that's really good. And again, you mentioned that, and this can be lost, in the details, that obviously, and we heard Andrew Aiken on a prior town hall talk about this, but this movement towards open source and having different contributors provide, to GitHub and to the tools that are available, and the code that's available outside of Swirls. I think that's really important. That's really a trigger for all of us growing, and also really to think open source and build with some of the open source protocols and mindset in mind. But it sounds like the TCK definitely is a piece of that, is part of the recipe for that.
Yeah. And I think it's really timely as well, because from my perspective, as I said early on, I see a lot of the funding requests come across my desk quite early on in the life cycle from the foundation perspective, and these are actual use cases where the full stack was built on Ruby on Rails, and they weren't interested in integrating any of the other SDKs. So our advice at that point was, well, our serialization protocol is protobufs, and we're using gRPC anyway. You can technically roll your own. You can create your interfaces and your stubs, and away you go. And what you've just described with the TCK addresses one of the concerns that they had, which was like, yes, we can do this, but how do we know that what we just built is compliant and will operate with the same fidelity as the officially approved SDK? So I think this reduces one more sort of barrier or obstacle, or whatever you want to call it, around the adoption, even if it's not following the standard adoption paths like use a JavaScript SDK and so forth.
Yeah.
So I think it's a very powerful thing, and probably something that we as an ecosystem need to be getting out there a lot more. Yeah. I guess while I've again got the talking pen, talking stick, Nana, can I trouble you please to dig into what our EVM strategy is going forward, and also like what are some of the main focus areas or items or pieces that we intend to be, I guess either doubling down on or introducing, or whatever the case might be.
Yeah, happy to. Simple and short, our EVM strategy is, we would say, EVM equivalence, right? As I had mentioned before, the network is EVM equivalent in the fact that we have a full-on EVM client that will process transactions the same way you would expect on Ethereum or any other chain that has a valid EVM client, which means what we really want you to do is to be able to copy and paste your contracts from another EVM chain onto ours, and that would work. And also just point your RPC endpoint to Hedera and it should work. So that's our strategy in a nutshell. Anything that doesn't allow you as a developer to do that is something that my team is focused on, and we go and fix, and that's a big part. That's the first, I'd say that's the first foundation there. The second would be the integration of a lot of these Web3 tools and dApps and others, right? Whatever it is, again, we're enablers. So whatever it is that you want to build, whether it's a DeFi product or a multi-sig wallet or whatever it is that you want to do, we want to be able to provide you the capabilities there. So now that we've sort of done and will continue to manage that EVM equivalence layer at the protocol level, we want to see what does that look like for your development tools? What does that look like for oracles? What does that look like for bridges? And so enabling these sort of different products and the strategies that they have to be able to make the products that are necessary for their users is what we're also focused on. And so some examples of that are, recently the Ethereum chain did their hard fork to Cancun. So our team is actually developing support for that as well. And so we'll upgrade our EVM client to be able to support those same transactions that Cancun on Ethereum can support. We're also, one of our other goals is to bring some of the native services that Hedera offers that other chains cannot through to smart contracts. So some examples here would be the HTS, which stands for Hedera Token Service. The tokens that can be created natively on the network have some extra properties that don't exist within ERC initiatives. So ERC20 for fungible, ERC721 for non-fungible, they have some specific functionality that they can do. The native Hedera token can do more than that. And so instead of just holding that on to people that use the SDKs in either Go, JavaScript, Java, we want to expose that to smart contract developers who say they want to stay within, EVM languages like Solidity or Viper. And so what that looks like is we expose these Hedera native services as if they were contracts. And so we call these system contracts. And so an EVM developer that comes from another network can come to Hedera, code out their smart contract, but treat the native service as a contract that offers additional functionality. And so now within your smart contract, you can, take advantage of that. So part of our strategy is also exposing more functionality as it comes out. Case in point, you'll see that in the frictionless airdrops HIP, you'll see that the new transactions that we're talking about will also be eventually exposed via smart contracts. So within your smart contract, a smart contract could do an airdrop in the same manner. Within your smart contracts, a smart contract could claim that, an airdropped token. And so that's also part of our initiative. So if I'm reiterating that, it's enable EVM development. It should work as you expect it in any form across different Web3 products. But then also we want to be able to expose the additional things that Hedera can do that other networks can't do, so that you can have the best first-class experience as an EVM developer.
Yeah, that's excellent, Nana. There was a question from the audience, which I think you have partially addressed. The question was around how does Hedera compare to other layer ones that use languages such as Move or Rust that provide parallel processing? Is there any more that you'd like to elaborate on that?
I think just at the high level, I thought this was an interesting question. I think it was a good question, especially in the space that we're in. It's like, there's certain languages that get all the airtime. Having been doing this for a quarter century, you can be successful in just about any programming language. The language itself isn't a determining factor as to whether you're going to be fast or not. Java, for example, has phenomenal multi-threading support, always has from day one. There are some things about each language that sort of gives it inherent advantages or disadvantages in different areas. That is true, but you're able to do like parallel processing. In fact, we do tons of parallel processing today in terms of like given a state tree, if we have to hash that state tree, we use many different threads to do that. Given some transactions with a whole bunch of different state signature or a bunch of different signatures on those transactions that we need to verify, we do that with a whole bunch of multiple threads. if you were to look at one of these machines that was under heavy load, you would see that every CPU was getting pegged. We do a really good job of making use of as many cores that we have. There is another level that we could go to in terms of parallel processing of the actual transactions themselves. Each transaction, actually, there's like a pre-handle phase, which is all done in parallel, and then there's the actual handle itself, which is done sequentially. And the reason is that parallelism inherently provides an indeterminate behavior. And at some point, you have to put everything back into fixed sequential order so that the end result is done deterministically. Because if it's not deterministic, then of course you're going to end up with one of those ISSs. And it's not as trivial as it seems on the outset. If you were to look on our network, for example, where today a large number of those transactions are being processed as consensus service transactions, the same account is getting debited over and over and over and over and over again. And so it's important for us to be able to do those in a specific order, because if that account were ever fail to have enough transactions, we need to fail on exactly the right transaction when that happens. So there is an area of research that's going on here actively in order to see how we can parallelize this. But we just recently, this is another one of the things that we don't have like a really great way to describe all this work that we've been doing. But one of the things that we did was a significant investment on the services code itself and architecture. And we call it internally, we call it modularization. If you go look at our issues, you'll see modularization. We've been at it for about a year. And one of the effects of that was that we redid the architecture in such a way that doing parallel processing is actually of the transactions themselves is something that we can tackle next. But whether it's actually a performance win or loss has yet to be seen. If you were to look in the high frequency trading space for Java, for example, they can get upwards of 20 million transactions per second, and they do it on a single thread. So what you do is before the transaction gets handled, whenever you have IO, you do that on multiple threads. The actual transaction handling would be on a single thread, and then any additional IO or other parallel processing you need to do after that would be done on multiple threads. But there is a significant cost to concurrency, so you have to take that into account as well. So anyway, in terms of like Move or Rust, there's nothing inherent in either one of those languages that makes it superior. That would mean that all is lost. It's really just the quality of your algorithms, and that'd be the same in any language.
Yeah. Well, that was a very rich explanation, Richard. No pun intended, of course.
I'm gonna say rich is another word for long-winded, and
no. It was nuanced and it was good, and that's what we love about this kind of conversation. It does require nuance. I think it's easy for us to kind of trivialize or just talk about these things as if they're trivial, but it obviously isn't. I think what you're describing certainly also gets into how you use mirror nodes, and I think that's a very big topic in of itself. It's something that I'm going to reserve you guys to come back at some point, maybe in a few months, to talk maybe at length about mirror nodes and how they interact. I think that's something that a lot of us are interested in, and it's a lot more nuanced than I think appears. But unfortunately, we have run out of time, and I want to respect everybody's time. Before I leave, just a little, a heads up about the next town hall that is on April 26th. So exactly a month from today at 10 a.m. Brandon Davenport is going to lead that one. It's around the music NFT community. So that should be an exciting one. We'll have a lot of news about that and social media posts and things like this. But in the meantime, if you're interested to hear more, understand more about the HR Foundry, please do go to hrfoundry.com. We have that regular standing meeting at 11 o'clock Eastern every Friday, and it's open. It's more or less like a water cooler for the developer community in Hedera, and we encourage all you guys to join us. And certainly Richard, Viv, Nana, you guys have participated before. We'd love to have you again. But that all being said, thank you so much for Richard, Nana, Viv, to be here on this. This was, I found it, I was making a lot of notes feverishly here. I found it really educational for me, and hopefully other people did as well. And really good to see you all, and thanks again. Have a
me also, Jim. I've got the pen.
Yeah, you have the pen, exactly.
Yeah, it's like I've been scribbling away wildly. To all our audience, thanks for joining us today, as always, and thank you for our lovely panelists taking the time to speak with us. And thanks, Jim.
Thanks, enjoyed it.
Thank you.
Okay, guys. Have a good
Take
day.
care, guys.
Yeah.
Bye.